12.1, Trig functions in right triangles. This lesson has been divided into 3 lessons. This is the first part. 12.1a, the Pythagorean theorem and special right triangles. Objective, find missing sides with the Pythagorean theorem and special right triangles. Here is the Pythagorean theorem. Notice a squared plus b squared equals c squared. A and b represent the legs. C represents the hypotenuse. There's a concept called Pythagorean triples. These are integers that when you put them into the Pythagorean theorem, they satisfy it, and it represents a right triangle. These are nice integers. And these are the basic Pythagorean triples, and then there's also multiples of them that also work. Let's go ahead and discover if the missing x will create a Pythagorean triple. So we're going to use the Pythagorean theorem. This is a hypotenuse. In this case, the hypotenuse is x. X squared equals 5 squared plus 12 squared. And then this is going to be 25, and this is 144. So x squared is equal to 169. Let's take the square root of both sides, and we're not going to worry about the negative part because we don't want a negative length. And the answer is 13. So when one leg is 5 and the other leg is 12, and then the hypotenuse is 13, and we say yes, this is a Pythagorean triple. All right, I'd like you to try 1, 2, and 3. Stop the screencast and see what you can do. Okay, here are the answers. Again, I substituted the hypotenuse in there, and then I found that the answer was square root of 52. Now, a triple means that all the sides will be integers, so we say no, not a triple. We're going to try this one. We're going to put all the numbers in. This time we know the hypotenuse, and then we're trying to find the missing leg, and we get 4. So these lengths will be 3, 4, and 5, and yes, this is a triple. In this particular problem, we're talking about a pole here, and there are 2 wires that are the same length that are supporting it. They're both 6, and the pole is 5, and we'd like to know how far that wire is to the pole, so we're looking for x. So this is an isosceles triangle right here. So we're going to put 6 into the hypotenuse, 5, and then x, and solve, and we're going to get the answer about 3.3 feet. Now this is not a triple, but this is using the Pythagorean theorem. Okay, let's take a look at the relationship on the sides of 45, 45, 90, and 30, 60, 90 triangles. We're going to use the Pythagorean theorem, and so this is going to be c squared is equal to 3 squared plus 3 squared. So c squared will be equal to 2 times 3 squared. I'm not going to make that a 9. Now I'm going to take the square root of both sides, and then c will be equal to, now here's a perfect square that can come out, and the answer is 3 root 2. Now let's do it again. C squared is equal to 5 squared plus 5 squared. So c squared will be equal, there's 2 of these, so 2 times 5 squared. I'm not going to make this 25 because I'm going to take the square root of both sides, and then we're going to get c is equal to, now this is a perfect square that can come out, 5 root 2. So this is kind of interesting. The hypotenuse here was 3 root 2. Here it is 5 root 2. So what can we assume about this c, and this c? Well, let's go ahead and look at the work that I've done. And if you guessed that the next answer was 7 root 2, you're correct. 10 root 2. And so in general, this is not a c squared, but a c. C will be equal to x root 2. So in other words, the hypotenuse will always be root 2 longer than one of the sides. And this is the gist of what we know about a 45, 45, 90 right triangle. We know that the hypotenuse is root 2 longer, and root 2 is about 1.414. So when you take a number, the side here, and you times it by here, we're going to make it longer. So let's talk about the sides of a 45, 45, 90. So a 45, 45, 90. We know that the side opposite 45 is x, opposite 45 is x, opposite 90 is x root 2. So it's root 2 longer than the legs. We're going to simplify this more by just working with the numbers 1, 1, and root 2, because this is the ratio between all the sides. And this is going to help us when we want to solve problems. Let's take a look at this one right here. I'd like to figure out what x is. Now you may already suspect that the answer is 8 root 2, because this is a hypotenuse, this is the side, and we know it's going to be root 2 longer. Now if you need this, you can also write 45, 45, 90, and we're going to make a proportion. And we know the ratio for a 45, 45, 90 is 1, 1, root 2. So I'm going to write a 1, 1, root 2. And I'm looking for the hypotenuse because that's what x is. So I'm going to do it opposite the 90. And then I'm going to write 8 right here. And then here's your proportion. And you can cross multiply. And you will get x is equal to 8 root 2. Some of you may have already known that, but here's an algebraic way to find it. Okay, let's go ahead and do this problem. Do you suspect that the answer is 5? Because this is root 2 longer here. If you need an algebraic way to look at it, 45, 45, 90, and we're going to set up a proportion. And we're going to write 1, 1, root 2. We know the hypotenuse is 5 root 2, and we're looking for the x. Now, we'll just find one x because the other x is the same. So we're going to, it looks like x is already by itself, so it's just a matter of this is the answer, but I'm going to do a little reducing here before, and so I get x is equal to 5. So some of you who suspected was 5, you're correct. Okay, your turn. Stop the screencast and see what you can do. And here's the answer. Notice that I went ahead and wrote out the proportion. I put the right number in there and I found x. Here I wrote out the proportion, put the numbers I knew, and then I cross multiplied to get y. All right, let's take a look at another type of triangle. This is an equilateral triangle, and in an equilateral triangle, we know that all the angles are 60. So that angle is 60, that angle is 60. This is 62, but it got divided. So if this is 60 and this is the altitude, which is 90, then this has to be 30, because remember, they have to add up to 180. Now, in this situation, all sides are 6, and we know that right here, this altitude has divided this isosceles triangle, and we know this answer is 3. Okay, so let's use the Pythagorean theorem to help us find b. So we're going to do c squared is equal to a squared plus b squared. We know we have 6. We know one of the sides is 3, and we're looking for the other side. So then b squared will be equal to, now this is 36, take away 9, and b squared will be equal to 27. Now I'm going to take the square root of both sides, and b is equal to, now I know there's a 9 in there, so this will be 3 root 3. So this is interesting. This is the short leg, and this is the long leg, and this is the hypotenuse. Okay, let's go ahead and do it again. We know that this is an equilateral triangle, so this is 60 degrees. This is 30 degrees. We know this is an isosceles triangle. The altitude is going to divide, and then so this length will be 5. So now I can use c squared equals a squared plus b squared. So this is 10 squared is equal to 5 squared, and then we're looking here for b plus b squared. So b squared will actually be 75 when I subtract the 100 minus the 25. Take the square root of both sides, and I know there's a 25 in there, so this is going to be a 5 root 3. Okay, so let's take a look at this. The short leg was 5. The long leg was 5 root 3, and the hypotenuse was 10. There seems to be some kind of pattern here. Okay, so and then the last one I went ahead and did, and sure enough, look at this. The short leg is x, the long leg is x root 3, and the hypotenuse is 2x. And this should suggest the next relationship, 30, 60, 90 triangle theorem. And it says that the hypotenuse is twice as long as the short leg. So here is the hypotenuse, and here's the short leg. They have a 2-to-1 ratio. And it looks like the ratio between the long leg and the short leg is a 1 to root 3 ratio. Look at this, root 3 longer. Now root 3 is about 1.7. It's not quite the number 2, so that's why multiplying by root 3 will not be bigger than the hypotenuse. That's why it's just called the long leg. So here's what we know. On a 30, 60, 90 triangle, the leg opposite the 30 is the short leg. We call that x. The leg opposite the 60 is called the long leg, x root 3. And the side opposite the 90 is called the hypotenuse. So here's the relationship, and this is in its simplest form if I want to just talk about the very simplest ratio. Okay, so let's go ahead and try to find this one, and the setup should be very similar to what I proposed for the 45, 45, 90. So 30, 60, 90. We're going to set up a proportion. And the numbers that we're using are 1 opposite 30, root 3 opposite 60, and 2. And then I'm going to go ahead and look at my hypotenuse, that's y. And I'm going to look at opposite the 30, that is x. And then opposite the 60 is 9. Okay, so what I want to do is I'm going to try to solve this right over here. So I'm going to write it over here, x over 1 is equal to 9 root 3. Now I can see I already have x by itself, so I just have to make this look a little better. So root 3 over root 3, and then x will be equal to, now this makes a 3, 3 goes into 9 3 times, so x is 3 root 3. Now I'm going to try to solve this one, so it's a matter of 9 over root 3 is equal to y over 2. So I'm going to cross multiply, and that'll be 18 over root 3 equals y. And I gotta make this look a little nicer. That's called rationalizing the denominator. Now this will become a 3. 3 goes into 18 6 times, so it's 6 root 3. So here's the answers that I found. I found that the short leg was 3 root 3. I found that the long leg was 9, and I found that the hypotenuse was 6 root 3. Now notice the short leg and the hypotenuse have this 1 to 2 ratio, and the short leg and the long leg, this guy is root 3 longer, because if I times this by root 3, I will get the number 9. Your turn. And here's the answer. Okay, one more time. Take a minute to stop the screencast. And here's the answer.